All right, so again, we're gonna just hit these middle three methods in this set of videos. So next we're gonna look at functions that cross. All right, so when you're dealing with these types of areas, sometimes the functions cross. So say I had this red graph and this green graph, and I wanted to find this area in here. All right, well, for this part, the green graph is on top, and for this part, the red graph is on top. So when I'm doing this problem, I'm going to separate it into two different integrals, because this one is going to be green minus red, and this one is going to be red minus green, using what we knew from before. All right, so it's just a basic idea of that. When you draw your functions and you see they cross, you basically have to separate out into multiple smaller problems because you want to make sure that the top function is always the same. All right, so we want to find the area between sine and cosine over the intervals of 0 to pi. All right, so we have to, again, first graph this. We have pi over 2 and pi. We have 1, negative 1. All right, cosine is the one that starts at 1, and it's going to go to 0, and then negative 1. And sine is the one that starts at 0. It goes up to 1 and back down. So we're finding the area between them. And we're looking here and there. And we're going up until pi, which is right there. All right, we're trying to find that yellow region. And we can see, just like in the picture I drew on the previous slide, there's a switch that happens at this point where the red graph goes from being on top to the green graph. So we need to figure out where that switch happens. And again, the switch happens when they're equal to each other. So it's when sine of x equals cosine of x. And when is sine equal to cosine, that's at the 45-degree angle. That's when x is pi over 4. All right, so now when I set up my integrals, all right, they give me the left and right point. So I know over here is 0 and over here is pi. And now I know that switch happens at pi over 4. So when I set up my integrals, I'm going to have 1 that goes from 0 to pi over 4. And that one is when the red graph is on the top. The red graph is the cosine one, so that's going to take cosine, subtract sine. I'm going to add to that the second region I want, which is from pi over 4 to pi. And that's when they switch, and now the green graph is on top. The green graph is sine, so that's sine of x minus cosine of x. So these two combining, this left-hand one will give me this region. The right-hand one will give me this other region where the green one's on top. And now for each of these, and I forgot the dx here. For each of these, we can basically just do them separately. All right, the first one, the integral, or the antiderivative cosine x minus sine of x. It's going to be sine of x plus cosine of x, evaluated from 0 to pi over 4. Sine turns into cosine, cosine turns into negative sine, so that's right. And I'm going to add to it this one, negative cosine minus sine of x, evaluated from pi over 4 to pi. And again, just double check, negative cosine turns into sine, negative sine turns into negative cosine. All right, so that's good. And now, again, I'll pause the kind of recording here and just work out plugging a bunch of numbers in, because it'll probably be a little boring to watch. All right, but the basic idea is I'm going to just evaluate these two separately and then combine those two answers. All right, so again, in yellowish orange, whatever color that is, plug in all the numbers, and just knowing that sine and cosine of pi over 4 both are square root of 2 over 2. Sine of 0 is 0, cosine of 0 is 1, cosine of pi is negative 1, sine of pi is 0. All right, so plugging all that in, simplifying these two things in here end up canceling, and you get 2 square root of 2 as your final answer. And it would depend on the units, but 2 square root of 2 units is the area between these two graphs. All right, so this is just kind of one step extra from the previous video. All right, if you recognize that there's a place where the switch, where one function switches being on top and one function switches to being on bottom, you basically have to separate it out into as many times as that switch has happened. So in this case, it happens once. If you were to extend this, because sine and cosine are just these infinite waves, you get a lot of times where they switch. You have to break it up into a lot of different integrals. After this one, the switch just happens once. We have two different integrals. All right, so that is kind of the second thing you might have to be worried about when you're finding the area between curves.